Hi, welcome to Exemplar Physics, where we learn concepts in an easier way. In this video, we are going to discuss resolution of vectors. We will learn what is resolution of vectors, how to resolve vectors, and why to resolve vectors. We will do some questions at the end to encapsulate the concept in much better sense. So watch the video till the end. Before that, let's find out the answer to the question asked in the last video. The question was, the forces which meet at one point but their lines of action do not lie in one plane are called. Options were A. Non-coplanar, non-concurrent, B. Coplanar, non-concurrent, C. Coplanar, concurrent, D. Non-coplanar, concurrent. So, in this question, the first line says forces which meet at one point. So, forces are meeting at one point, therefore, they are concurrent. And the second line says the lines of action do not lie in one plane. That means they are not coplanar, hence they are non-coplanar. So, the answer would be non-coplanar, concurrent, option D. Now let us jump into today's topic, that is resolution of vectors. Let us understand this concept with a simple example. Let's say there is a block on which two forces, say force F dash and F double dash, are acting simultaneously. As we know, forces are vectors. Let us write them with arrow on the top. So since these two forces are acting on the block simultaneously, in which direction will the block move? The block will move along that direction along which the resultant or the effective force acts. How to get the effective force? We need to do the vector sum of the two vectors, that is F dash and F double dash. How to do vector sum? We'll be discussing that in the future videos. For now, let us say vector sum of these two forces is F. And also please believe this statement for now, that the resultant of two forces are going to be anywhere in between these two forces, and for simplicity I am taking F in here. The resultant may not be here. You will learn about that in future videos, but for just simplicity F is acting there. So the body will move along this force, this block will move along this force. Now if suppose I rub these two forces, or these two forces becomes invisible, so you will see only this block moving along the force F. If I ask any one student what could be the reason for this force F, then different students may give different answers. For example, if I ask a simple mathematical question that A plus B is equal to 4, and let us take A and B as natural numbers, and if I ask the students what could be the values of A, different students will give different answer. Suppose one student will say A is equal to 1, then B would be 3, that gives to 4, or some other student may say A is 2, then B will be 2, so the answer will be 4. Some other student may say A is 3, then B will be 1. This also gives to 4. Which of the following is correct? All are correct. In the same way, if F dash and F double dash are not given or not visible, and if I ask what could be the reason for this force, different students will give different answers. One student may say F is because of F1 and F2. Another student may say no, it is because of F3, F4, or some other student may say this is because of F5, F6. I am not drawing further pairs of forces because it will become clumsy, but I think you have understood this. So force F can be written as F1 plus F2 or F3 plus F4 or F5 plus F6. Like this, we can write any number of pair of forces which is responsible for F. So this process of splitting a vector is called resolution of vector, and the parts obtained after resolution are known as components of given vector. So F1, F2 is component of F, F dash, F double dash, that is also component of F, F3, F4 components of F, and writing F as F3 plus F4, that is resolution. Writing F as F5 plus F6, that is a resolution, where F5 and F6 are components of F. Now just think, wouldn't it be good if all the students got the same set of components, and the analysis and understanding would become very easy. That's why we utilize a new set of components called as rectangular components. What are rectangular components? If the components of a given vector are perpendicular to each other, then they are called rectangular components. These components are very useful components. Let us understand this in much better way by using 2D Cartesian coordinate system. You know, in 2D Cartesian coordinate system, we have two axes, x and y. Let us draw them. So this is a x-axis, this is y-axis, and let us take a vector v. Let us take a vector v which makes an angle theta with the horizontal. As we have already studied, the length of the vector indicates its magnitude. So let us write origin as O, then one of the end, let us write it as A. So OA is magnitude of vector v. Let us simply write it as v. If this angle is theta, then this angle will be 90 minus theta, as x and y axes are perpendicular to each other in a Cartesian plane. Let me draw a line perpendicular to x-axis from A. So it meets x-axis say at B. In the similar way, if I draw a line perpendicular to y-axis from A, it meets at say C. So in this figure, OB is x component of V. So we'll write it as Vx, and OC is y component of V, and we will call it as Vy. That means vector V is equal to Vx plus Vy. So vector is V and its components are Vx and Vy. When I add both, that is going to be V. Now, if you see that figure, you can clearly see a right-angled triangle where O, B and A are its vertices. This angle is theta. This length is Vx. I'm just taking the magnitude part. And this length, see here, this length AB is parallel to OC. So this length is nothing but AB, that is OC, which is a y component of V. And again, I'm taking just a magnitude part. Now by using trigonometric ratios, what is Vy by Vx? Vy perpendicular Vx, adjacent side, perpendicular side by adjacent side, that is tan theta. Let us write it as equation number 1. Also, if I write, okay, what is OA? OA is magnitude of V. So magnitude of V, let us write it as V. So if I write OB divided by OA, OB adjacent side, okay, adjacent to this angle, adjacent side, and that is equal to Vx, and OA, that is hypotenuse, that is equal to V. Vx by V, adjacent side by hypotenuse, this is equal to cos theta. Hence I can write Vx is equal to V cos theta. This is equation number 2. So what is Vx? Vx is x component of V. How to get x component of V? Magnitude of V into cos theta. Similarly, if I write AB by OB, AB, that is the perpendicular, or you can say opposite side, by OA. Sorry, this is OA, opposite side by hypotenuse. What is this? AB is equal to Vy, OA is equal to V. So opposite side by hypotenuse, this is going to give me sin theta. Opposite by hypotenuse, sin theta. So I can write Vy is equal to V sin theta. So this is our equation number 3. Vx is equal to V cos theta, Vy is equal to V sin theta. So if a vector V is making an angle theta with the horizontal, then its components would be V cos theta and V sin theta. I can write sin theta as cos of 90 minus theta. Just remember this, will be useful. Just remember that, that will be useful. I can also write v sin theta as v cos 90 minus theta. That means I am writing this part, this vector, in terms of this, that too in cos. Okay, this is 90 minus theta. So what is Vx? Vx is nothing but the projection of vector v on x-axis. Projection of vector v on x-axis. What is Vy? Projection of vector v on y-axis. You can understand this like this also. Suppose if I have a torch or a light source through which the light falls perpendicularly on the x-axis. Light is falling perpendicularly on the x-axis. So there is vector v which will block the light. So how much portion on x-axis will OA block the light? That is OB. Its shadow will be formed only at OB. That's why this is the projection of vector v on x-axis. Similarly, if I have a source of light which is parallel to x-axis and perpendicular to y-axis, so what would happen? This vector will block the light and form a shadow whose length will be equal to OC. So OC, which we are writing it as a Vy, is nothing but its shadow or projection. So Vx is projection of vector v on x-axis, Vy is projection of vector v on y-axis. So if you want to write this in terms of cos, then Vy is equal to v cos 90 minus theta. Now we are going to use rectangular components from now onwards. Therefore, the directions along the x-axis is given a special notation or is denoted by a special unit vector. What are unit vectors? We have already discussed. So this direction of x will denote it by I cap. So what would be this direction? Minus I cap, or you can also say I hat, plus y-axis, we call this as j cap, and minus y direction, that is downward, vertical downward, we'll call it as minus j cap. So we will be, from now onwards, we'll be representing x-axis, direction along x-axis with I cap and direction along y-axis with j cap. Can you guess what would be the direction along z-axis? It will be denoted by unit vector k cap. So xyz ijk. So now I can write this equation like this. V is equal to, so Vx, vector Vx is nothing but v cos theta, and this is the magnitude, and what is the direction? I cap, plus v sin theta, what is the direction? Y, j cap. So this is the notation of resolution of vectors in 2 dimensions. I hope you have understood. This is our equation number 4. Now we will be analyzing furthermore. Like for example, what would happen if I square and add 2 and 3? Let us do that. So squaring equation 2 and adding with square of equation number 3. So what can I write here? Left hand side Vx square, right hand side V square cos square theta. I have to rub this part. Let me rub the first equation part. Next, second equation, third equation, Vy plus Vy square, and what is on the right hand side? v square sine square theta. So I can take a v square as common, so I'll have cos square theta plus sine square theta. What is cos square theta plus sine square theta? 1. What is v square? V square is equal to vx square plus vy square. So what is v square? Magnitude of v to the power 2, square of magnitude of v. So what is magnitude of v? Magnitude of v is vx square plus vy square under root. So let me put that in a box. So here we have got a magnitude of v in terms of their components. How much is that? Vx square plus vy square. You have to remember these things. This will make the analysis very simple. Remember, v is magnitude of vector v. How to get it? Horizontal component square plus vertical component square. See here, any vector v will have two components. One, its magnitude. Two, its direction, which is denoted by its unit vector. So unit vector of v, I am writing it as v cap. So what is v cap? So I can write v cap is equal to vector v divided by v. So vector v, what is magnitude of v? Magnitude of v is vx square plus vy square. So this is also an important derivation. So total we have written 6 equations. I hope you have understood them. So let me write the important conclusions one by one for you. If we have a vector v which makes an angle theta with the x-axis, then vector v can be written as v cos theta I cap plus v sin theta j cap. If you want to write both terms in cos, then this will become v is equal to v cos theta I cap plus v cos of 90 minus theta j cap. Now 90 minus theta is this angle. Number 2, magnitude of v. Magnitude of v is nothing but x component of v square and y component of v square. So vx square plus vy square. Number 3, cos theta can be written as vx by v because vx is equal to v cos theta. Sin theta can be written as vy by v. Unit vector of v is given by vector v divided by magnitude of v, that is vector v by under root of vx square plus vy square. Now this all are true for two-dimensional plane. So let us expand our analysis for 3 dimensions, but I am not going to derive them. I will write them corresponding to these formulae. So 3 dimensions will have 3 axes. So these are the 3 axes. Say x-axis, y-axis, z-axis. So unit vector along x-axis I cap, unit vector along z-axis j cap, unit vector along y-axis j cap, z-axis k cap. Suppose we have a vector v, this is vector v, which makes an angle alpha with x-axis, an angle beta with y-axis, and an angle gamma with z-axis. So how can I write that in rectangular components? So we are going to make this 2D into 3D. So if it is 2D, then we'll write v cos theta I cap plus v sin theta j cap. Now see here, sin theta can be written as cos 90 minus theta. Here we are given each angle corresponding to each axis. Therefore, no need to write in terms of sine. All terms we can write in terms of cos. So I can write v is equal to, v cos, so how much angle it is making with the x-axis? Alpha. Next, how much angle is it making with the y-axis? Beta. And the unit vector is I j cap plus v cos of the angle which it makes with the z-axis gamma into k cap. So this is rectangular components of v for 3 dimensions. How to get the magnitude of v? If this is 2 dimension, then v is under root of vx square plus vy square. If this is 3 dimensions, then you have to extend the square root for vz square. This v cos alpha is nothing but vx, v cos beta is nothing but vy, v cos gamma is vz. What is vx? Projection of this vector along x-axis. Say the vector is like this. So what is the projection of this? So what you have to do? You have to throw light perpendicular to x-axis. When you throw light perpendicular to x-axis, a shadow will be formed on x-axis, shadow of this vector. What is the length of that shadow? That is the projection Vx. In the same way, the shadow that falls on y, that is Vy, V cos beta, and similarly for z, V cos gamma. So if it is for 2 dimension, cos theta is equal to Vx by V, sin theta. So we'll not write sin theta here. We'll write it as cos, not cos alpha, cos beta, and one more term cos gamma, which is equal to, you can guess, Vz by V. Similarly, unit vector V by V, that is a vector V divided by its magnitude. So its magnitude is Vz square. So I hope you have understood the results. Still, if you have any doubts, please ask in the comment section. An important point to note here: cos square alpha plus cos square beta plus cos square gamma is equal to 1. These cos alpha, cos beta and cos gamma are also called as direction cosines. Now we have learnt how to resolve vectors. Now let us think about why should we resolve vectors. Resolution of vectors, especially into rectangular components, makes the analysis simple. This you will understand when we do questions. The operations like vector addition, product of vectors becomes easy. Motion of a body in a plane is little complicated, but it becomes easy when we resolve it into its rectangular components, since they can be studied individually and independently. This was first suggested by Galileo for the projectile motion in his dialogue on the Great World Systems 1632. If you have understood the concept, hit the like button. If you still have some doubts, comment it. I will surely help. We will do some questions now. Question number 1. The component of a vector is option A, always less than its magnitude, option B, always greater than its magnitude, option C, always equal to its magnitude, option D, less than or equal to its magnitude. So as we have taken the example of vector V, which we have written as Vx I cap Vy j cap. So Vx, how much is Vx? Vx is V cos theta. That is the x component. What is Vy? Vy is V sin theta. So just was this is how we have written for 2 dimensions. Now if you see here clearly cos theta, values of cos theta, sin theta. Value of cos theta or sin theta are from -1 to 1. If magnitude of vector is V, then if I multiply with cos theta or sin theta whose values are between -1 to 1, what happens? Suppose if I multiply with cos theta, V with cos theta, so its value decreases, its value will be less than V, right? Unless cos theta is 1. So I will put equal to sin also. So V cos theta is less or equal to V. What about V sin theta? Same. So which option is correct? Option D. Less than or equal to its magnitude. Let's do question number 2. If a vector A makes an angle alpha, beta, gamma respectively with x, y and z axis respectively, then sine square alpha plus sine square beta plus sine square gamma is equal to option A 0, option B 1, option C 2, option D 3. Please pause the video and try this question and then check the answer. So I hope you have got the answer. So we have seen the sum of squares of direction cosines is equal to 1. That is cos square alpha, cos square beta, cos square gamma. If I do the sum, that is equal to 1. And you also know this identity in mathematics, that sine square theta plus cos square theta is equal to 1. So how can I write cos square theta? Cos square theta can be written as 1 minus sine square theta. So that's the same thing I'm going to use here. I'm going to write cos square alpha is equal to 1 minus sine square alpha. Cos square beta, I am going to write it as 1 minus sine square beta. And cos square gamma, I am going to write it as 1 minus sine square gamma. And how much is the sum? 1. So see here, 1, 1, 1. How many ones? 3 ones. Minus, if I take minus as common from sine square alpha, sine square beta, sine square gamma, so I can write sine square alpha plus sine square beta plus sine square gamma is equal to 1. Take this to the other side, bring 1 to this side. 3 minus 1 is equal to sine square alpha plus sine square beta plus sine square gamma. So how much is this? 2. So what is the answer? The answer is 2. Option C. If you are noting it down, you can pause the video at any time. Question number 3. This question is for the viewers. The question is, the horizontal component of weight of a body of mass m is option A, mg, option B, mg by 3, option C, 0, option D, infinity, where g is acceleration due to gravity. Let's go to question number 4. The vector A is equal to I cap plus j cap, where I cap and j cap are unit vectors along x and y axis respectively, makes an angle dash with the x axis. The options are 0 degree, B 45 degree, C 60 degree, D 90 degree. So which one of them is true? So A, I can write it as AX I cap plus AY j cap. So what is AX? AX is equal to A times of cos theta. And if you compare this, how much is that? 1. So keep this as equation number 1. Similarly, AY, you can write it as A sin theta, and according to the question, this is also equal to 1. Write it as equation number 2. So what shall we do? Let us divide equation 2 with 1. So left hand sides first. A sin theta divided by A cos theta. Now right hand sides. So A gets cancelled out. Sin theta by cos theta. Tan theta is equal to 1. So theta is equal to tan inverse of 1. Since the vector is in the first quadrant, therefore theta is 45 degree. So tick mark the option there. So the answer is B. And the last question, 5. If a vector has x component of minus 25 units and a y component of 40 units, then its magnitude and direction of the vector is. So options you can see. Option A, 5 root 89 units. Sine inverse minus 5 by root 89 with x-axis. Option B, 5 root 89 units. Cos inverse minus 5 by root 89 with x-axis. Option C, 45 units. Cos inverse minus 5 by 9 with x-axis. Option D, 45 units. Sine inverse minus 5 by 9 with x-axis. So pause the video and solve it. So x component given in the question. Let us take the vector as v. So vx is equal to minus 25 units. Vy is equal to 40 units. Then what is its magnitude? Magnitude v is equal to under root of vx square plus vy square. Now put the values. Minus 25 square plus 40 square. 625 plus 1600. So how much is this? Root 2225. So at the end we have 25, therefore this is divisible by 25. 2225, 25, 5 fours are 5 fours are 5s are 5 8s are 9s are 89 is not divisible, so I can write it as a 5 root 89. So magnitude is 5 root 89. So option either A or B is correct. Now what is cos theta? Cos theta equal to x component divided by mod of vector v. So we know all the values here, all the values are here. So vx is how much? Minus 25. What is magnitude of vector v? 5 root 89. So cos theta is equal to 5 by root 89. Therefore theta it makes minus 5 by root 89 with x-axis. Remember, theta is made with x-axis. So option B. So that's all we have in this video. I hope that you have learned something. I hope you have enjoyed this video as much as I have in making it. Please share this with your friends and family members and subscribe to the channel. Bye bye.